Well, what we're looking at is an HP5381A. It's rated as an 80 megahertz frequency counter. I have a faceplate on the front that would mislead you and tell you it's a 5383A, which is a 500 megahertz or a 520, depending on which year it comes from. But the only reason that I have that is because the original faceplate was horrible. So by putting this different faceplate on here, it's a much pleasanter look. This looks white. It's readable. It has a kind of a newish look to it. The other one was extremely yellowed, had a couple of really bright patches in it where some stickers had been, and what was underneath didn't yellow, so it was uneven. So that's why I went ahead and I utilized this faceplate, which was from a defunct 500 megahertz unit, to give a good look to this unit. And I think I don't know. I might make a little dymo label for it just to indicate what it is. I'm not sure. If I do, it'll accompany the unit. I don't think I'll attach it. I'll let it be the decision of whoever gets the unit. But I just turned this unit on a little while ago. It hasn't been on in a week. I calibrated it a week ago. And at the moment, it's connected to this rubidium source. It's outputting a 10 megahertz signal that's accurate to more than 8 decimal places. And right now I am on a 10-second average, and what it's telling me is I am within 4/10 of a hertz of being exactly 10 megahertz. Now if I put this to the 1-second average, we should see it pop up 10. There we go. So if I put it to the 0.1 second average, you can see that it's reading 10 megahertz. And if I go to the 1-second average, the 1 disappears off to the left, and we're flashing between 9,999,999 to 10 million. And then if I go to the 10-second average, then we're able to see the 1/10 of a hertz. We'll have to give it a moment to cycle. The unit has been repainted. We'll come back and look at the unit has been repainted. The finish is nice looking. Gives it a much newer look. Very attractive. The scratches and markings from different kinds of labels and stickers and so on are gone. We have some nice rubber feet on the back to replace the long ago broken rear feet or stand. And then on the rear, get a look at it here. We have an external oscillator input. We can go internal or external, so you could run this off of say a rubidium if you wanted. And we see that it was probably from Ohio State University at some point. So if any of you ever went to Ohio State, you got a chance to own a piece of their equipment. So right now we're within a 1/2 of a hertz of 10 megahertz. And what we're going to do now is we're going to take this thing through its paces, and we're going to see how she performs. Okay, well, we've connected the unit up, and we're connected to this PTS 500 up here. The PTS is going to provide us signals from somewhere over about 100 megahertz down to about maybe 0.6, 600,000 hertz. Then we're going to switch to this HP, and we're going to go to the lower frequencies. Right at the moment, we're putting in its rated 80 megahertz, and as you can see, we're reading 80 without a problem. I'm going to go ahead, though, and we're going to take it up. So let's go 90. There's 100. The overflow indicator is on. The 1 is off to the left. You had to know that that's what it is, but we are reading 100. I can make it 101 so we could see that we're responding that way. All right, let's go 110. If I go 111, it doesn't quite read it, so 110 seems to be the limit. Let's go 9, 109, 108, 107, 106, 5, 4, 3, 2, 1, 100 even, 90, go back to 80, 70, 60, 50, 40, 30, 20, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 900 kilohertz. Now we'll go ahead and turn our time base to 1 second, so we'll just read a little bit better. All right, we got 900 kilohertz, 800, 700, 600. See if we can get 5. All right, we got 500. 500 kilohertz. We're going to switch now to this HP, and we'll take her from 500 and take her down. All right, we're now connected up to the HP, and we've got 500 kilohertz dialed in. We're reading 500 kilohertz on the counter, and we're going to walk it down. 400, 300, 200, 100 kilohertz, 90, 80, 70, 60, 50, 40, 30, 20, 10, 9 kilohertz, 8, 7, 6, 5, 4, 3, 2, 1 kilohertz. All right, change our range. And we're right back at 1 again. And let's go to 900 hertz. 800, 700, 600, 500, 400, 300, 200, 100. All right, we got 90 hertz, 80, 70, 60, 50, 40, 30, 20, 10. Didn't do that right. There we go. 9, 8, 7, 6, 5, 4, 3, alright, let's kick ourselves into the 10-second mode. We'll give ourselves another decade of resolution. Okay, I think we've hit our limit. Whoop, there's 3. 10-second average, we got 3. Let's go to 2. There's the first round. We gotta wait for the second one. There's 2. Let's go for 1. Don't think we're gonna get 1. So we read from 2 all the way up to about 110 megahertz using this unit. And it reacted very, very well through the entire range. It's nice looking. We got a good stand. It's going to come with a nice manual with some 11 by 17 size schematic diagrams, and makes it very easy to read. And we'll also have a nice set of new probes to come with it. There'll be the alligator clip, the BNC, very common, easy to use set of probes, and we'll get you going right away. So you'll have a nice looking counter with all the peripherals as if it was a new unit. So happy bidding, thanks for listening. Let's go.